Hello everyone, we're here to make another video about factoring. Hopefully everything is going well with the practice, keeping the different kinds straight. Pretty soon we'll be mixing them all up and trying them on our own, but first we're going to expose you to each different kind of factoring. And this is probably my favorite type of factoring because it seems to be the easiest for me, and for some students. It's called factoring the difference of perfect squares. Now if we understand what these words mean, doing this will be very easy. What is a difference of perfect squares? What does the word difference mean? Well, I hope you're thinking to subtract. And do we know what perfect squares are? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. But also, things like x squared is a perfect square. When I said things, I was kind of referring to variables. X squared, a squared, b squared. X to the fourth is actually a perfect square. We won't get into anything that tough today, but just let you know what's coming. You could also have a coefficient in front of there besides 1. You could have 4x squared or 9y squared. Variables don't always have to be x's, though we tend to like them to be. So now, if we want the difference of perfect squares, we can have two perfect squares that are separated by what sign? You guessed it, subtraction. So we could have something like x squared minus 16. We could have 4x squared minus 81. We could even have something as complicated as, say, 100 x squared minus y squared. Now, what we're going to do in this lesson is we're going to learn how to factor these differences of perfect squares. And the good news is it's pretty easy. If you know your perfect squares, it's easy, I guess. Recall yesterday when I asked you in the video, or maybe it was over the weekend, what is the coefficient for x when we have x squared minus 16? Well, if we were to rewrite this, we could write this as x squared plus 0x minus 16. Uh-oh. So if we think of it this way, we need numbers that multiply to be negative 16 and add up to 0. Well, if two numbers are going to add up to 0, well, let's see here. The factors have to add up to zeros, which we made that comment there. The numbers multiply to the c value. Well, in this case, it's the difference of perfect squares, so really this is a negative perfect square. Well, two factors of a perfect square that add up to 0 have to be the same number, which is the square root of 16. But you're going to have a plus 4 and a negative 4, which add up to 0. Now, that's kind of nice. The product of the first two terms of each polynomial is also a perfect square. So that means we have it written out as x squared minus 16x. That is the difference of perfect squares, which I call DOPS. Sometimes when I'm feeling lazy. I picked that up last year and I like it. DOPS. So if I want to factor x squared minus 16, I'll rewrite this over here. We need numbers that multiply to negative 16 and add up to 0. That's going to be negative 4 and positive 4, which adds up to 0. So we factor this by writing x minus 4 times x plus 4. Pretty good, huh? Sorry for the pause there. I was a little bit thinking of something else. Let's see here. Let's do some other examples. We've got some good ones. Let's try example 1. We'll say n squared minus 81. Now, hopefully we know our perfect squares at least up through, say, 144. So, n squared minus 81. N's a perfect square, 81's a perfect square, so we can write this as, well, the square root of the first term goes in the first spot, n and n. The square root of the second term, the square root of 81, goes in the second spot in each of the binomials, and they're separated by two different signs, a positive and a negative. It makes no difference whether I put the n plus 9 ahead of the n minus 9 as long as they're both in there. I think that was better explained when we did the whole thing together than when I broke it down into small pieces. So let's try another one that is relatively simple. X squared minus 36. Maybe if you're feeling good about yourself, pause the video and see if you can get the answer before I explain it. Okay, I'll start trying to explain it now. We'll take, and we notice it is the difference of x squared because 36 is a perfect square. So let's see, we need factors of negative 36 that add up to 0. Or I really don't like to write down the table when it's a difference of perfect squares. I just jump right in and say, okay, it's x minus 6 and x plus 6. The x is the square root of the x squared. The 6 is the square root of 36. I put the two different signs in. And that's my final answer. Let's try one that's a little tougher. Let's try, here we go, 4x squared minus 9. Now, you might not see 4x squared as a perfect square right away. 4 is a perfect square in the variable. X squared is a perfect square. So we got to think here, what are we going to put in the first spot? Well, we're going to put the square root of 4x squared. The square root of 4 is 2. The square root of x squared is x. So 2x squared and 2x squared. The square root of 9 is 3. And, well, since there was a subtraction there, we put a minus and a plus, and we're done. Now, please keep in mind that something like this, 4x squared plus 9, that is not a difference of perfect squares because it's a sum. That's a sum. So that one is not factorable. Also could be thought of as prime. Let's try a couple other ones that do work out, though. Let's try out 25x squared minus 1. And let's put another one down here. 49x squared minus 64. Why don't you give them a moment? I'll give you a moment. We'll pause the video. You can try them. Okay. Let's see. The square root of 25x squared. What's going to go in that first spot? Well, it looks to me like 5x is the square root of 25x squared, so 5x goes in the first spot. The square root of 1 is 1. So we'll put a plus and a minus 1. The next one we have 49x squared minus 64. What's the square root of 49x squared? Oh, let's see here. That's going to be 7x. And what's the square root of 64 is 8. So we have 7x plus 8, 7x minus 8, the difference of perfect squares. Wonderful. I never want to go too far past 10 minutes, but let's take a look at one of these. 4a squared minus b squared. Now, I never said both perfect squares couldn't be variables. All the other ones had a variable in one term and then just a coefficient, or I'm sorry, just a constant in the other term. This one has variables in both terms, but it is still a perfect square. Or I should say a difference of perfect squares, because both parts are perfect squares. The square root of 4a squared is 2a, goes in the first spot, and the square root of b squared is obviously what? It's obviously b, plus b minus b. Let's do one last one here. We'll let you try it, and then we'll call it a day. Okay, I'll pause it so you can think. Well, there's the answer. Okay, have a great evening. We'll talk more about this in class tomorrow.